In this tutorial, we will discuss the chemotherapeutics, and from the chemotherapeutics, our discussion will be about the antibiotics, and we will be further specifically studying or discussing with you guys the cell wall inhibitors. Before we get right into the topic, let me tell you people about the points that we're going to discuss in our this lecture. The point number one will be the introduction of the antibiotics, the types. Then we'll be discussing the cell wall inhibitors. And in the cell wall inhibitors, we'll be talking about the beta-lactam antibiotics and non-beta-lactam antibiotics, which are actually also known as the miscellaneous antibiotics. And further, we'll be discussing in our this lecture the mechanism of action of the beta-lactam antibiotics, and our specification in this will be the penicillins. Means we'll make people understand about this mechanism of action by means of the example, that is the penicillins. And next, what we'll be talking about will be the resistance, that how these bacteria, they actually show resistance against these antibiotics. And in the next point, we'll be talking about that how to counter this resistance then. Means how to make effective our beta-lactam antibiotics. So we'll be talking about that in the last step. Now let's proceed from the very first point, that is the introduction of the antibiotics. Antibiotics. Well, the first point is how we define the antibiotics. Simple. These are actually the chemical agents that either kill or inhibit the growth of the microorganisms. What are antibiotics? They're actually the chemical agents. They're actually responsible to kill or inhibit the growth of the microorganism. Just remember these two very important points, killing and inhibition. Now the next point is the types. We have actually two types of the antibiotics: broad spectrum antibiotics and narrow spectrum antibiotics. These broad spectrum are also known as the wide spectrum antibiotics. This is actually about a range, means that antibiotics that are covering a broad range of microorganisms or a wide range of microorganisms, and narrow are actually covering the small range of microorganisms. Let me give you a simple example that suppose we have a broad or wide range antibiotics. These will be actually effective against a number of microorganisms, suppose 50. These antibiotics will be effective against 50 microorganisms. But the narrow range antibiotics, they will be effective against 5 to 10 microorganisms. This is the very simple understanding about the broad or wide range antibiotics or the narrow range antibiotics or the narrow spectrum antibiotics. Broad spectrum, narrow spectrum antibiotics. Okay, this is the short understanding to the point regarding antibiotics. The next is the cell wall inhibitors, our main discussion. Basically, we have beta-lactam antibiotics and non-beta-lactam antibiotics. These both are actually responsible to inhibit the cell wall synthesis. So that's why these are given the name as cell wall inhibitors. And these beta-lactam, they are different from the non-beta-lactam miscellaneous by just one thing. That one very important point is the ring. This is known as actually the beta-lactam ring. Now penicillins, cephalosporins, carbapenems, monobactams, these all have this particular ring, whereas this isoniazid, vancomycin and some other, they don't have this particular ring. That's why they are placed in the miscellaneous antibiotics, whereas these penicillins, cephalosporins, carbapenems, monobactams, they are all placed in the beta-lactam antibiotics because they all have the beta-lactam ring. That's it, the very simple understanding regarding the beta-lactam and non-beta-lactam. You got the concept? They have the beta-lactam ring. Now, in this discussion, we will be proceeding our discussion from the mechanism of action of the beta-lactam, and we'll tell you people about the mechanism of action of the isoniazid and vancomycin in our next lectures. In this lecture, we'll be focusing the beta-lactam antibiotics mechanism of actions, and we'll be giving you example of the penicillins in this particular lecture. Before we get right into the mechanism of action, let us know about the structure of the bacterium first. You know that we have cell membrane and cell wall in most of the bacteria. Well, we have already explained the gram-positive and gram-negative bacteria. If you need information regarding that, you have to visit our channel for those lectures. Coming to the point. So we have cell membrane and cell wall in a particular bacterium. Okay. We have penicillin binding protein on this particular cell membrane. This is actually responsible to do the synthesis or to complete the synthesis of the cell wall. And you guys know that the cell wall is made up of the peptidoglycan chain, where we have NAM, NAG units, N-acetyl muramic acid, N-acetyl glucosamine. They chain up together, they make the peptidoglycan chain, and this chaining, they have actually pentapeptide protruding. So we have one chain at upper side, another one down. So these both chains actually are kind cross-linked and fixed together by means of this penicillin binding protein, which is actually one of the transpeptidase enzyme. This actually facilitates the cross linkage. What? The cross linkage between these pentapeptides. So like this, what will happen? By means of this penicillin binding protein, this cell wall will be actually a kind synthesized. So now when we give the beta-lactam antibiotics, example penicillin, what are they going to do? Here we have the penicillin. This penicillin will come and will direct the penicillin binding protein, which is actually a transpeptidase. So its function was to cross-link the cell wall to complete the synthesis somehow. Okay. So what penicillin does is here, penicillin will bind to the penicillin binding protein. Its mechanism, that is actually the cross-linking, will be a kind decreased. So you can say it will be inhibited. Transpeptidase mechanism is actually inhibited. No cross-linking. In the meanwhile, these penicillin binding protein will activate autolysin enzymes. Now these autolysin, the name is indicating, this, when it is activated, this will start breaking the cell wall. Auto means self-license breaking. So after activation of this autolysin by means of the protein, penicillin binding protein, when this activates these autolysins, they will start further breaking the cell wall. So like this, penicillin is actually inhibiting the penicillin binding protein. Like this, its function, which was supposed to cross-linking the pentapeptides, means it was actually responsible to do the synthesis or to finish the synthesis of the cell wall. So like this, now there won't be any kind of further formation of the cell wall. And in the meanwhile, by means of activation of the autolysins, this activation was actually done by the penicillin binding protein. So now when these autolysins are activated, they are further breaking the cell wall. So you can say in a nutshell, two things are happening. One, the cell wall synthesis is not going to be done. Number two, there will be the breaking of the cell wall. So like this, what will happen to the bacterium then? Here we have the bacterium. So you can say it is surrounding fluid like water, etc. So this fluid will then start diffusing into the bacterium. When it enters in the bacterium, then what will happen? This fluid will exert the osmotic pressure. Now this membrane is actually very weak. Before it was having a cell wall to protect this membrane. Now there is no any structural support available for this membrane of the bacterium. So this will then lyse. That's why the penicillins are known as bactericidal antibiotics. So this is the way how the penicillins are actually going to lyse, you can say kill the bacterium. Now what happens, sometimes the bacterium or the bacteria, they develop the resistance. Now why do they develop and how do they develop this resistance? Very simple. When we are using time and again the same particular antibiotic, then that's that bacteria, after a long time, they develop the resistance. Now how they develop? Very simple. By two very common methods. That is, number one, modification of the penicillin binding protein. Number two, beta-lactamase production. Come to the very first one, how they modify the penicillin binding protein. You know, when we indicate the particular antibiotics for a long period of time, due to this genetical mutation, some bacteria, they develop a modification in the penicillin binding protein. This modification is actually a kind of structural change in the penicillin binding protein. Before, when we were giving the penicillin, it was supposed to target the penicillin binding protein. Now, when we are giving the same penicillin, it will no more be able to bind to the penicillin binding protein. Why? Because this bacterium has changed, has modified the structure of the penicillin binding protein. The very first point we got means it is actually modifying the structure of the penicillin binding protein. Number two, it is going to produce the beta-lactamase enzymes. Now this beta-lactamase enzymes, when they are produced, these will come and will cover the cell wall. So they will be available on the cell wall of the bacterium. So here we have our beta-lactamase. What will happen now? So whenever we give the beta-lactam antibiotics, they have, the beta-lactam ring. Now these beta-lactamases, they will actually break this beta-lactam ring. And this beta-lactam is actually the very structural and functional ring of the beta-lactam antibiotics. If this structural functional ring is not available, then there won't be any kind of action observed of these beta-lactam antibiotics. So like this, by means of the modification of the penicillin binding protein and production of the beta-lactamase, the bacterium or all the bacteria, they show the resistance. And we have another resistance also, that is actually of porins. Regarding gram-negative point of view, it is observed that we have the pores in the cell membrane of the gram-negative. So what they do, they actually close those pores, or they actually narrow the pore of those pores. Then what happens, then these beta-lactam cannot enter through that membrane. So like this, gram-negative are actually showing the resistance. So these three are the very common methods by means of which the bacterium or the bacteria are actually showing the resistance. Now, how to counter this resistance? Very simple. For now, we have some beta-lactamase inhibitors by means of which we can actually counter somehow. How? Like, very simple. We have tazobactam, clavulanic acid, and sulbactam. These are actually the beta-lactamase inhibitors. They will actually inhibit these beta-lactamase enzymes. Now, these are actually given with the beta-lactam antibiotics. Okay, these two will be given at a time. So what will be we giving, indicating to the patients? Number one, the beta-lactam antibiotics plus some beta-lactamase inhibitors plus beta-lactam inhibitors. So we'll be giving these two for particular therapy if that person or if the bacterium they have developed a resistance. So beta-lactam will show its action in the presence of the beta-lactamase inhibitors. How? Like, first of all, when we give the beta-lactamase inhibitor, they will inhibit the beta-lactamase enzyme. So if the enzyme is now inhibited, then what will happen? Then the path is free for the beta-lactam to go and bind to the penicillin binding protein and to show its mechanism. That's it, very simple. So like this, we can actually counter the resistance of some of the bacteria.